Let's explore async/await, a modern way to handle promises in JavaScript. Async/await provides a clean and readable syntax for writing asynchronous code. One major problem that async/await solves is callback hell and complex promise chains. Consider the following code where we need to fetch a user, then their posts, and finally the comments on the first post. This leads to nested then calls, making the code difficult to read and maintain. We fetch the user with the user ID 123. Then we fetch the posts using the user ID. After that, we fetch the comments using the first post ID. And finally, we log the comments to the console. If any of these steps fail, we catch the error and log it. Async/await introduces two keywords to improve asynchronous JavaScript: async and await. The async keyword is used to declare a function as asynchronous. This means the function will implicitly return a promise. The await keyword is used inside an async function to pause the execution until the promise is resolved. Here's a basic example of an async function. We define an async function called fetchData. Inside this function, we use the await keyword to wait for the fetch request to complete. Once the response is received, we extract the data using response.json, and again await for it to complete. Finally, we return the data. This approach makes the asynchronous code look and behave a bit more like synchronous code, which enhances readability. Error handling in async/await is straightforward using try and catch blocks. Let's look at the code. Inside the try block, we fetch the user data and convert the response to JSON. If any error occurs during these operations, the control is transferred to the catch block, where we can log the error or perform other error handling tasks. This ensures that our asynchronous code is robust and can handle errors gracefully. Async/await allows you to write sequential and parallel asynchronous code. In the sequential example, we first await fetch A and then await fetch B. This means fetch B will only start after fetch A has completed, taking a total of 2 seconds if each fetch takes 1 second. In the parallel example, we use promise.all to run fetch A and fetch B concurrently. This means both fetches start at the same time, and the total time taken is only 1 second, assuming both complete within that time frame. Choosing between sequential and parallel execution depends on whether the operations are dependent on each other. Here are some best practices to keep in mind when working with async/await. Always use try-catch blocks for error handling to gracefully manage any exceptions. Use promise.all for parallel operations to improve performance when operations are independent. Avoid await-in loops for independent calls to prevent unnecessary delays. Keep async functions focused and small to maintain readability and manageability. In summary, async/await offers cleaner syntax compared to traditional promise chains, making asynchronous code easier to read and maintain. It provides better error handling with try-catch blocks, ensuring robust code. As a modern standard, async/await is widely adopted and improves the overall development experience. Async/await makes asynchronous code readable and maintainable. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.